Hope you guys are having a beautiful day today. Today we're going to talk about the properties of the special parallelograms called rectangles, rhombuses, and squares. And our objective is for you to be able to use and apply the properties of rectangles, rhombuses, and squares. Alright, so a quick overview of what we're going to study today. We have three types of special parallelograms: rectangles, rhombuses, and squares. So first things first, a rhombus is a parallelogram with four congruent sides. So technically, at the end of the day, a rhombus is going to have four congruent sides. Now, if we want to talk about a parallelogram with right angles, the most general type is a rectangle. So a rectangle is a parallelogram with four right angles. Now, you might be like, hey, what about a square? But the thing is, a square has all of these characteristics. So a square is a parallelogram with four congruent sides and four right angles. So the biggest thing is, a rhombus has sides that are congruent, a rectangle has right angles, and then a square has both of those characteristics. Alright, so let's talk about rhombi. So a rhombi has all the same properties of a parallelogram. So in a parallelogram, opposite sides are parallel. If you look at consecutive angles like angle A and angle D, they are supplementary. Opposite angles like A and C are congruent. And the diagonals bisect each other. So let's go ahead and come to our picture, and let's go ahead and draw our two bisectors. So we have a bisector that goes from A to C, and we have a bisector that goes from B to D. So these segments here are congruent, and these segments here are congruent. Another cool thing about the diagonals of a rhombus are that the diagonals are perpendicular. So that means the diagonals form four right angles smack dab right there in the middle of that rhombus. And then the last cool thing about the diagonals of a rhombus is they bisect a pair of opposite angles. So that means that here the two angles at angle B have the same measure as the two angles there at D, and the two angles there at A and the angles here at C are also congruent. Alright, so example number one. The diagonals of a rhombus ABCD intersect at point E. Given that BAC is 53 degrees and D equals 8, we're going to find the following measurements. So if DE is 8, that means that EB is 8. And basically what that means is that DB is going to be 16. Whoops, can't really write it that color. DB is going to be 16. So now if I want the measure of CED, what you've got to remember when we look at the picture is the diagonals of this rhombus bisect each other. So right here in the middle, or they have four right angles, they're perpendicular. So those are right angles. So this angle here is 53, this angle here is 53, and this angle here is 53 because they bisect opposite angles. And now, if you look, the three angles of a triangle add up to 180, so 53 plus 90 plus our missing angle adds up to 180. And if you do the math on that, 90 minus 53 looks like 37. So angle CED, so if I mark what I know, you know me, I'm a big picture marker. Here we have 37, 37, 37, and 37. Woohoo! Okay, so that means that angle CED, which is right here in the middle, angle CED is pretty easy, 90 degrees. And if we went DAC, DAC is right here. So DAC is 53 degrees. And then BAD takes both of those 53 degree angles to put them together to get 106. Right. So if I want angle ADC, angle ADC, if we recall from the last picture, was 37 degrees. And now they tell me that AB is 3x minus 5. So here we have 3x minus 5, and DC is 2x plus 4. So I know the opposite sides of my rhombus have the same length. So 3x minus 5 equals 2x plus 4. I'm going to move my x over, my 2x over, and then add 5 to both sides. So in the end, x equals 9. So now we're looking at AE and CE. So if I look at my picture, I know that AE and CE are congruent because the diagonals bisect each other, which make E a midpoint. So that tells me that 2x plus 1 is going to equal 4x minus 7. So I can do my quick algebra. And in the end, I get that x equals 4. All right, moving on, rectangles. So again, rectangles have all the problems. All right, so doing some examples. We have quadrilateral QUAD, so we need to label that QUAD. And it says the diagonals intersect at point S. So we have a point S right here in the middle. They tell us that we know QS and we know US. So the thing about this rectangle is all 4 of these little pieces are going to be the same. So if QS is 6y minus 5, that means US is also going to be the same length, so we can set those two equal to each other and we can solve. Doing some pretty quick algebra here. So the value of y equals 4. So now if we look, the next statement says that QA is 10x minus 4, but UD is 26. Since both of those are diagonals and diagonals are congruent, I can set this equal. So 10x equals 30, and good algebra, x equals 3. All right, so another rectangle. So if we just think about what we know about the picture, they tell us, I know that QS in the picture equals 10, so they didn't really tell us, they didn't draw that on the picture, but if QS is 10, then each of these segments is 5. The other thing about this is we have some congruent triangles because these two angles are vertical. The top triangle and the bottom triangle are congruent by side angle side. So here we have some 34-degree angles. The other thing about a rectangle is we know that these 4 angles are right. So if we take 34 degrees and we find the complement to 34, 90 minus 34 is 56. So that tells me that I have a 56-degree angle here, 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 and here. So I want you to hit pause and take a moment, and I want you to answer these 6 questions. All right, welcome back. So angle SRT is going to be 56 degrees. RP, so RP is half a diagonal, so that's going to be 5. RS, the left side of the triangle is 6, so the right triangle side of the triangle is also 6. Angle QPR, I didn't find angle QPR, but if you take angle QPR is this angle right here. So that tells me that if I take 180 and I subtract 34 twice, that's going to give me my answer. So 180 minus 68, 120 is going to be 112 degrees. QP, so Q to the center is going to be 5. And QR is, oh wow, I don't know. I do know. I can do the Pythagorean theorem. So this little piece here is going to be 3, which means I could find x here. If you do the Pythagorean theorem, you get 3 squared plus x squared equals 5 squared. 9 plus x squared equals 25. And x squared equals 16, which makes this little piece up here 4. And if both of those pieces are 4, then the length of QR is going to be 8 units. And last but not least, squares. Squares basically have all the properties of all the parallelograms. So all the properties exist here. They have the properties of a rhombus, so the diagonals are perpendicular, and each diagonal bisects a pair of opposite angles, and the diagonals are congruent. So if we do a problem with a square, they tell us that LK is 3. So based on that, I know I have right angles because this is a square. My diagonals are congruent because a square is a rectangle, so all of these are going to be 3. Right here, I have some nice perpendicular lines because this is a rhombus, and I feel like I am missing a piece of information. So give me a second, let me see what we're missing, and we'll go from there. Oh, I'm not missing any information. I'm just not thinking. Because these sides are congruent, and this is a 45, 45, 90 triangle, because I have a right angle right here, which means in the square, all of these angles are 45. Miss Schwartz, major brain fart. Okay, here we go. Okay, so now if I finish filling these in, angle MKN, so MKN is the angle in the center, which is 90 degrees. KN is 3. LPK is one of my 45-degree angles. MP is 6. Angle LMK is another one of my 45-degree angles. And LP is looking at, we're going to figure out LP. So that's a Pythagorean theorem problem. So if you take this triangle and we look at this one of these triangles here, it doesn't matter because they're all 4 congruent. But what we would have to do is take my leg squared plus my other leg squared, and it equals my hypotenuse squared. So 9 plus 9 equals LP squared. So this is going to be the square root of 18, which is 9 times 2, and you're going to get 3 radical 2. All right, so for today, those are basically the properties of a parallelogram, and we will study those a little bit more when we get to class tomorrow. Have a great day, and I will see you guys soon. Bye-bye.